determining the value of V that minimizes the energy exerted by a fish traveling a distance of L units, where the speed of current is U units in the opposite direction, of course, and is a constant. Well, I think to optimize energy, I will differentiate finite critical numbers. This may not be an absolute extrema question, but it is an extrema question, so let's look for local extrema first. I shouldn't say first. It's not an absolute extrema question. Let's just simply look for critical numbers, period, not first. Okay, you know what, everybody? I'm sorry. I'm going to have to first rewrite. Because a V is the variable in question. Can I rewrite this whole fraction before I differentiate as such? Sorry, it just makes my life easier. Now differentiating with the quotient rule? Sorry, you're writing correctly. Differentiating with the quotient rule? Excuse me, double checking my arithmetic. In building a sine graph, is that coming through? It is. So where are my critical numbers? Are they at V could be 0, V could be U, or V could be 3/2 U? Now, if V is like, I meant to say 3/2 U, 3/2 U. Now, V is so extremely high, it's like a billion. I think it makes absolutely everything positive. If V is really close to U, but still slightly bigger than it, who cares positive? Who cares positive? But V is just slightly bigger than U, just like a 2U minus 3U, which is a negative quadrant. Now, V is less than U, can we just not care? If I'm traveling at a speed less than the current of the water going against me, I'm not going to travel any distance at all. So who cares? And who cares if I'm traveling at negative velocity? Not even dealing with it. So it looks to me like over the realistic domain of my function, the original function E is changed from decreasing to increasing. So clearly, if I'm trying to minimize energy, I want to minimize the energy by traveling at 1.5 the speed of the current that's going against me. Studies actually do show that this mathematical model is accurate. Fish really do behave in such a way that to minimize energy, they travel at 1.5 times the speed of the current going against them. Now, what's going on at the other extreme ends? Well, look what happens if the velocity a fish is traveling at is really, really close to the speed of the current going against them. Then it's going to be swimming for an extended period of time to create the distance, and therefore there's a lot of energy expended. At the other extreme, that's sort of like the fish is traveling at a speed of light or speed of sound, which is going to require so much energy the fish is never going to be able to attain that.